Okay, and we are back live. And I'm here with Cyril again to tell you some more exciting things about his work with LiveCode.
Hello.
So I'm going to hand you over.
Okay, this session is on apps for teachers to use in their class. It's not for learning to.
Yeah, you're okay, you're good.
There's a delay between what I'm hearing and seeing.
Oh dear.
It is not for teachers to learn to program apps, but to take those apps, add their own content, and give them to their students to use on their own devices at home. So instead of playing mindless games at home, the students can be playing games with the material the teacher covered that day or that week in class. And also, it's made as easy as possible for a teacher to add content. They could also modify the graphics and even change the operation of it. I've given a number of LiveCode games here. We have 3 sets of videos. The first video is on a simple review game, much like Kahoot, if any teachers have used Kahoot in their classroom. The second one is on a range of games where they can change the graphics. And then the final video, if we can get to it, is on writing their own Siri or having their own chatbot. Make the app an expert on the subject. So if a student has questions, they can ask the chatbot instead of waiting the next day for the teacher. Likewise, the teacher could also give the chatbot and have the students add the content and give it the intelligence. So if you're teaching Spanish, have the students take what they learn in class and put that material into the chatbot and have their chatbot speak Spanish. So you'll see more as we go on. The first video is on a simple game for reviewing. Okay, and then we run it. First of several apps that are designed for teachers to use in the classroom with their own content. It minimizes the programming that a teacher must learn and maximizes the flexibility for them to add their own content. This one is QuizMaster. It is patterned after Kahoot, or you Kahoot it on the web, which allows teachers to upload their questions, and then students go to a web page either with their cell phones or their tablets or computers and go through the questions as a class. This instead works with individual students. They can upload the questions and practice them anytime they want. So as the program opens up, it looks like this, and the first thing it does is ask you for your questions to load. I put them in a file called myquestions.txt. This is a common text file. We will look at it in a few minutes. And you just open it, and there's your first question shows up and 4 alternate answers, and they pick the answer. So how many are in a dozen? 12. What is 13 called? Too many? Wrong. It was a baker's dozen. So if the student gets a question wrong, then it tells them correct answer for reinforcement. In the story about the cow that jumped over something, what did he jump over? The cow jumped over the moon. And 2 plus 2 is 4. You don't have to have 4 answers. It'll only populate questions with enough answers. Alrighty, so you can try it again. And each time you do this, it replays the questions, but it changes the position of the correct answer. So you can see that it randomizes it, so the correct answer is not always on the same button. And you also have the option of loading new questions. So if they would if you gave them a text file each week, this would allow them to review previous weeks. Okay, the file that is loaded looks like this. Basically, the questions are, the first is the question that you ask, how many in a dozen. The next one is the correct answer, and then after that are the incorrect answers. So the question always has to be first, separated by a comma, then the correct answer, comma, and then the other answers with commas on them. The program will ignore any line starting with slashes, which in programming is a comment, and it will also ignore blank lines. So basically, you can edit this file in Microsoft Word, in Pages. You could even do it in Numbers, Excel, Notepad, as long as you save it as a text file, a TXT file, and you separate each section, each item with a comma. And that's it. We will stop for questions.
Okay, I'm not seeing any questions at the moment, other than about Webinar Jam. We had some issues with it last time. It's going fine just now. So if you want to carry on to...
Okay, no questions. So I guess we could load the second part of this, and it shows how the students can, or how the teacher can change the operation of this depending on the grade level. For instance, an elementary class, you may want to make it simpler. High school class, you may want to make it a little bit more difficult. So let's look at the modifications that you can make to this program to accommodate different levels of students, different grade levels, and also for your personal preferences. So we go load up the program, the LiveCode, into LiveCode, and we go to the card script. All right, the first place you may want to do modifications on Get File. This is where we load the file into the file with your questions into it. I did use the default myquestions.txt. You can make this any file name that you want. And I look in the downloads, assuming students are going to download programs to their download sections. When they download it, it will be there. If you're doing this for, let's say, elementary or middle school students, and it's on your desktops at school, then you may want to change downloads to desktop and then have the file every week, have different file there for them to practice with. This is entirely your option. You can also just remove this code completely and just default with the with whatever you save the program with. Once you load your questions and answers into here and save the program, they're already built in, so you do not have to load them from the desktop or from another file. The next place is when you get the questions. All right, what this does is go through the questions one by one and randomizes where they are. And then when it's over, it answers game over. Good job. You have the option of changing this and giving them different reinforcement. On mouse up, when they answer the question, if they get it right, if whatever button they choose was correct, basically all I do is add 1 to field score. You can remove the 2 slashes and give them an answer after each question saying, good job, you did well, you're right, attaboy, wow. but that slows the game down. Older students might not like that. Likewise, if they get it wrong, I put up the right answer, item 2 of the current question. So remember, the way we formatted each line in the questions file, the first item is the question, comma, the second item was the correct answer, comma, and then the other answers were separated by commas. So this, if they get it wrong, reinforces and tell them what the correct answer is. And you feel free to change this or eliminate it. Older students might want it to go faster and not have pop-ups that they have to click on. Younger students may appreciate this. So it's based on your preferences and how you want to do it. Likewise, you could have some sort of naming for week 1, or this week is on speaking vocabulary for some aspect of biology, and just have different titles. All right, so that's basically the customization that's easiest to do and with very little problems.
Okay, you're back.
Okay, no questions yet.
No, there is a question. I spotted a question.
If you look at the code isn't the most best code that can be written, because what I did at the last minute was I stripped away the logic code and put it on the stack. And what I left on the card script was as easy to read as I could make it for teachers who do not understand LiveCode, but enough to modify it a little bit. Alrighty, the next
I can see that Brian had a question.
Video is on a matching game, and there's a whole set of LiveCode programs that you'll see that I uploaded, and they range from drag and drop all the way up to live action games. Again, the teacher can add the content, can add the graphics, and then modify it at a higher level to speed it up, other things. This is the educational games can be used basically at the elementary school level, but I have some students that wrote organic chemistry questions and worked into building molecules. So there's a wide range of ages that these type games can accommodate. I'm showing this video mostly for the graphics end of it. So let's watch this. At another game of matching or drag and drop. In this case, you try to match the colors. We made this simple because we named the colors, but it's always fun to give the different names. Make this say green, but actually be red. All right, let's look at how we can modify this and add your own content and add your own graphics. So let's start out with adding, skinning these buttons with graphics so that instead of matching colors, we're matching animals. We start out by importing our graphics. You click on File, Import as Control, Image File. And I have a rabbit, and I bring the rabbit in. Now, the way that I find the easiest is if we stretch out the screen. We're going to put our rabbit over here. Consider this object as a master copy, and we're going to use it to skin these buttons. So we need a place to put our master copy, and I usually stretch the screen card, put it on this side, and then make it smaller when we're ready to deploy it. Now this rabbit is too large for the box, so we right-click and go to its property inspector, and we go to Position, and we can size it down to about the right size for the button, and then we lock it in place. This is so that it doesn't return to its original size. Images are like springs. They'll always return to the original size. Whether you stretch them or make them smaller, they try to return. Every time you open the program, it's going to go back to its original size. So we always have to lock the size and position. Then we go to the basic properties, and we note, see, this is image rabbit. We note its ID. In this case, the ID is 1010. We use that number to skin it. So we go over to box, we go to icons, and if we put 1010 and click away from it, you can see the rabbit go there. Now we go back to the basic, and for the box, we no longer need the name to show, so we uncheck show name. We don't want the color, we want the background to be opaque, and we don't want a border around it. So we unclick all those items. And if you want to be really good and safe, you go to position. Notice there's buttons to fit content. The button is a little bit bigger than the image, so we can say fit the button to the size of the rabbit. And that makes it just right. Next step, let's make this button. So we click on this button. We go to icons, put in 1010, click away, the rabbit shows up. Go back to basic, uncheck opaque, uncheck show name. We don't need borders. And then we go to position, and we fit the button to the rabbit. All right, let's import file, import as control, another image file. Let's put a star. So now this star is too small, so we need to bring it over here and make it a little bit larger, the size that we want. And we go to its property inspector, and goes position and lock it in. Then we go to the home. Notice the ID is 1010. So if we want this to be a star, you go to icons and put 1010. Whoops, 1011. There's the star. So you can see the skinning of it. We go back to, well, let's go to position, fit to the size of the star, go home, uncheck opaque, uncheck show name, take off the borders, and we can import another image. Let's go to Dropbox, graphics, shoe. All right, we have a shoe here. Its ID is 1010, and we size it. We'll size it a little bit smaller. We go to position, lock the position. If you notice, there's a background to this one. We can always take an eraser and erase around it with the tools. And we have the option of setting it a different size. Okay, we locked it in place. Now if we want to make this the shoe, We go to Property Inspector, and if you remember the number, it was icon 1012. And now that becomes the shoe. We can go to Position, fit it to the content. Go to here, take off the peg, take off the name, take off the border. And now we are done. We put our card back to its original size, thus hiding all our masters. And we have a program that runs. Lastly, you might want to add some color to the card inspector. So if we go to color, background fill, we can fill it with a color, or we can fill it with a pattern, and there are many available here. Let's just do that. All right, and the final modifications you might want to make is on what happens when you move it there. If you don't like buttons popping up all the time, you go to Edit the Script on the box, the main button that you're moving, and here's the code. When you put the mouse down, you grab it, and if it intersects, we answer good job, you got it right, else try again, and we always move it back to this location. So you can change the text here and play some music. Sometimes I imported, if we go back to here, we can do file, import as control, an audio file, and sometimes I would download clapping or booing and add those so you could play music, play sound effects, and things like that. So that's it. As I said, you can make this chemical symbols, try to match the final symbol to make cyclohexane, or the ideas and the content is all up to you. Now let's go to questions. Okay, we have some questions up here. Let's see. Are the questions in standard format, GIF? And that's Brian's question. No, they're just in comma delimited fashion, which I thought was simpler for the teachers to use. Robert asked, during your teaching experiences, have you seen learning styles or other teaching methods that have helped? Yes, there's a lot of different teaching methods, a lot of ways of implementing this. I've just found that doing it on a project basis where the students automatically start doing a game or app of their own is more, they learn the code as they go along, rather than teach the code, then do the project. Do the project and learn as you go. And is that the question that answering your question? Let's see, you also said about, are the teachers are engaged instead of putting the focus on code syntax? I think engagement is important. They'll learn the code syntax as they go along. And you can reinforce the syntax as they're working on their projects, as questions come up. And so, as I mentioned, instead of teaching code and the syntax, yada, 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 and then doing some program with it, doing the program, they have to research and sometimes learn the syntax themselves. You get it wrong a couple times. You learn by doing. And I mean, in the real world, often you're given a project to do, something to write, and you may or may not know the language. And so programming is a lot of research and trial and error, looking at other people's code. So this is a way that is effective for most people getting work done. So it also works out to be an effective way of teaching students. And as I said, they pick up the code, and then at breaks or when a question comes up, you can also take that time to reinforce the syntax of the code, edit the other ways of doing it, and so forth. Okay. There's been some research that's saying that learning styles is not that important. And it's not that effective. And this is more along the lines, I've seen a triangle where they say you learn 10% by listening, 25% by seeing, and then it goes on up. The highest numbers were 85% by doing and 95% by teaching. Good questions, Robert. That's a nice place to start a discussion about what works best in the classroom, learning styles, different, how do you handle different situations. But I've taught a number of different subjects: physics, chemistry, math. I've had all sorts of students, from really good students to students that were in and out of jail routinely, all different learning styles. And you try to adapt the teaching to the style of the student. Teaching computer science is very easy because you get their interest. And once with LiveCode, once they see how easy it was, then they really get engaged. And once you have them engaged, they're listening and they're learning. Okay. Interesting side story. My principal gave me a class of students that were in danger of failing out of school. They were the typical students that sit in the back, horse around, make comments, put their heads down, don't do any work, and no teacher could motivate them. And they would have dropped out within a year or so. He put them in my class, and the first day we start doing programs right away, and we do a different project every week. And at first, typical, true to character, they just sat there, behaved the way that they behaved in other classes. But when they saw first what we were doing, some of the neat projects we were doing, and then second of all, how easy it was. I think a lot of them who are dealing especially with low esteem, self-esteem issues would say, I could do that. And gradually they started engaging. So by the end of the quarter, they were all working, turning in fairly decent programs. Some were not the kind I would give out, but they at least learned and did. When we switched to Python, they lost interest. I mean, one by one, they sort of died away. So this would be an interesting topic to investigate as far as keeping students in school. Okay, no more questions? No more discussion points? Okay, let's go. I uploaded a number of games, going from live action games and all sorts of other games. And modifying those are just a matter of adding content, adding graphics, and you can change some of the speed, the timing, having a clock, having a countdown timer, things like that. But what I want to go on to next is the chatbot. I put this under artificial intelligence, but it really isn't. It's very crude. Those of you that remember way back at the beginning of computers, ELIZA was a big sensation. ELIZA was a psychiatrist program, and people would log on their terminal and carry on conversations. And the point was, how long can you carry on a conversation with this? It has morphed to nowadays, there's a Turing test or some type of contest where every year they award huge amounts of money to whichever chatbot can keep speaking the longest, engage, and handle difficult to answer questions. And this is basically what your Siri, Google Now are. So here's the video on the one that we build in class. This is a project, but modified so any teacher can use it, not only to teach their material, they can make it a Spanish expert, and then when the students aren't around, they could ask when they can't talk to the teacher, they could ask the chatbot the answer, or turn it around and have the students build their own chatbot and use what you teach them in class to add the content, and then see who comes up with the best chemistry, chatbot, whatever. So here's the video. This is the chatbot teachers app, where you could use it either to make an expert in your field and something for your students to question, or you could give it to them and let them try and make theirs an expert in your subject. As they take notes, they add it to this chatbot and it becomes smarter and smarter. How it works is you type input. For instance, if you would say, I am hungry.
What are you hungry for?
Okay, I have speak on. I'll turn that off. All right, hamburger. What would you like on your hamburger? Okay, ketchup. What else? You can make it an expert in your language, like what is a verb? And it says a word used to describe an action, state, or occurrence. How about an adverb? A word that modifies an adjective or verb. I have an A+ in maths. Tell me more about your A+ in maths. So it has some simple type of intelligence. So you could use this for probably the best use is allowing the students to see how smart they could make their chatbot with material that you're teaching in class. To change or load a different set of intelligence, you just load a table, and we're going to load up my chatbot, and now it has the intelligence of whatever I programmed for it. All right, to give you an idea of how this is constructed, here is the intelligence that I've added to this. And if you notice, this is consisting of two fields. The first is the word that it's keying in on, and the second is the response, and it's separated by a tab. Usually you separate items with a comma, but you might have a comma in yours, like this has a comma in there. So you have to you separate it with the tab. Probably give a clear idea if we show you. There it is, my created in numbers. So you could create your instructions either and your responses either in Word, numbers, pages, Excel, anything that can write it out as a tab delimited file. So these are the keywords that it's searching for, this first column, and then this is the response from the chatbot. So you can have it used to teach or have your students use it to have some fun with the notes that they take in your class. All right, looking at the code where you might want to make modifications. This is on the card, and on an open card, it selects a file to use. If it's and again, it keys off the desktop in my chatbot.txt. Now, if you have an elementary class or a middle school class and you don't want them to be able to input it, or you don't want them to worry about files, you could just delete this section, and whatever you save the LiveCode with instructions, you could load it with your own and save it, and it will work without having to worry about loading. You might also want to change, if you want them to be able to load their own files, you might want to change the pathway and the name of the file. Okay, the logic behind this is, first we check for some specific words. For instance, if it's empty, we say, please say something. If it's no, we say, why is so negative? Yes, are you sure about that? If you could say, this is about you, not me. So these are the hard-coded. You could add to this if you want, like to put in your name and have some sort of canned response to it. The next section looks for specific words. This is what reads your table. When it reads in your table, it reads it as a list, as an array. And then all it does is look for each word, whatever the student types, it looks for each word, seeing if you have some sort of response geared to that. And then the third section is if you do things like I like, I hate, I want, we want to throw it back at them. So if they say, I hate school, we're going to return with, why do you hate? Whatever they typed. I want, why do you want? Whatever they typed. And you feel free to add to this. You see the that. And if they actually go through this and get a word that doesn't match anything that we have random responses. So if we don't identify any word, interesting, tell me more, do you really think so? You don't say. So you can modify this and put whatever responses you want into this. So that's it. Basically, you load the table. It has to be a text file separated by tabs. And it now has the intelligence. So if I say, I like maths, why do you like maths? If I say, me, why you? I am happy. Tell me more. It didn't recognize that because I didn't program the word happy, so it encourages them. This is based off the program called ELIZA, which was the first example of base artificial intelligence. It was a psychiatrist that would constantly ask you questions and see how long it would can keep you talking. Alrighty, that's it. Have fun modifying them.
Okay.
That's it. It gets interesting. Students really get creative. One student programmed his to understand street talk. Another girl programmed hers all in Spanish, so it only spoke Spanish, so she could practice her Spanish. Get a lot of interesting. One girl who belonged to the Environment Club made hers an expert on recycling. You could ask it about any symbol, any recycling, anything about the environment, and it knew most of the questions that you would probably ask it. Which means, any questions from anyone there?
I'm not seeing any questions at the moment.
Yeah, it's interesting that most of the programs that I have done are created by students. They come up with the ideas. You give them the basic measure of how to move something, how to do something, and they come up with the ideas. They always have something they want to do, try, some vision of what their app or their game is like, and you're always trying to problem solve with them, which allows you to teach problem solving, which is one of the nice aspects of LiveCode. You have more time to teach problem solving, breaking a problem into smaller pieces, analytical thinking, logic, instead of worrying about semicolons, matching braces, and all the other archaic rules that accompany other languages. We did the chatbot in steps. We usually took 2 weeks, because what we would do is we would start with a basic chatbot with just the if then else statements. You know, if there's a word dog, the response is tell me more about your pet. If the word was mother or father or son or daughter, tell me more about your family. Then we would have them add more vocabulary. So after a while, you get to maybe 20 or 30 words and it starts getting tedious. And we then go to, there must be another way to do this. So we think, how about having a list of words? And we just look through the list. So then we wrote a program, wrote code to eliminate the if-then-elses and just do look through a list. And then when we looked at the vocabulary of a 6-year-old is about 2,000 or 3,000 words. And I think a 9-year-old is like 20,000, 50,000 words recognized and 20,000 words speaking, adaptive, so, as they say. Then there's got to be a better way because we can't go looking through 20,000 words. So then that's a good opportunity to teach them about arrays. So this is a beautiful way of teaching them about if-then-else statements, switch statements, array lists and arrays, and then some other aspects without spending class time, book time, going through it. And, you know, in a traditional school, you teach them if-then-else, and then let's write some programs with if-then-else. Now let's look at lists, and this does. As far as hours, class was 45 minutes a day. I just gave them a base chatbot with the if-then-else statements. And in a couple days, when the words got too many, we would talk about lists and how to do lists. So an hour, 45 minutes a day, 2 to 3 weeks to cover all the materials. If you had a really good class, you cover in 2. Sometimes you take, some classes will take 3 weeks. So that's 45, that's hour and a half, 4.5 hours, 20 hours. Am I familiar with ready-made data files that can be used with such chatbots? Not really. I haven't looked for them. let's see. Robert asks, any info on how students work with pseudocode where they learn about how a computer thinks? When I taught languages regular way, I tried doing pseudocode, but they always want to jump into writing the code. This way, they're writing pseudocode, and then when they go, we've gone on to Python and Java, and which is another interesting story, because I originally taught 6 months of Python, or no, 1 semester of Python, 1 semester of LiveCode. And the last year I switched around, did 1 semester of LiveCode and 1 semester of Python. The problem is they understood programming so well from LiveCode that we went through 4 months of lessons, 5 months of lessons in Python in 2 months. And they wanted to learn another language. And we had gone through all the assignments for the Java, or then we went to Java, and we spent in another 2 months, they learned Java, that we were actually doing some AP computer science Java. Let's see. Yeah, that's basically what we're doing. We're taking their interest in the project and doing an app or a game, and we use that to, in the process of doing that, learning about it. Just like when you go to fix a sink around the house. You get out a book, you look it up on the internet, you learn bits and pieces about plumbing in trying to accomplish some goal. And that sort of is what we're doing here. But again, because of the simple syntax and the ease of learning LiveCode, they learn the concepts better and were easier to learn than more difficult. They weren't mired down. In teaching Python or any other language, students often get stuck on starting counting with 0. You know, lists always start with zeros, arrays start with 0. They get stuck with some of the Boolean constructs. There are many places in traditional languages that they don't have to worry about in Python, in LiveCode, and then when they switch to another language, they can easily adapt. Oh, okay, I know about lists and arrays. I have to start with 0? Okay, that's quirky, but I'll do it. Any other questions?
That looks...
But and then the project also serves to attract more girls into and minorities, because there's a creative aspect of this. They're not stuck writing the GCD of every number or the square of every number from 1 to 100, or doing all of the other programs that you can find on the internet. You could Google and get the code from there. That's the biggest problem right now in computer science, is cheating. It's too easy to find the code elsewhere. But when they're designing their own game, there's always something different in their games, and it's not quite as easy to take code from another place and adapt it to yours. So it forces them to learn. We did not do too much loading on cell phones. They knew they could do it, but I just ran into too many problems with, you come out with a new version and then you've got to load down new Xcode, or it just got to be too much of a problem putting them on their individual cell phones or tablets. And what was interesting is they really didn't care. Knowing that they could do it if they wanted to was enough. That wasn't important to them. It was at the beginning, but once they knew how they could do it and how, you know, they didn't worry about it anymore. But a lot of them did load it on their own phones. We have a couple students that are making $400 to $500 a week with their apps on Apple Store. A couple students have been offered $25,000 for their apps. One of our students got a full scholarship to the Apple Developer Conference in San Francisco and taken on stage as the youngest developer at age 13. We've had students go on and win hackathons and that. So they learn it and they do very well. I think it's all due to LiveCode and then just doing things that they live in the digital world of cell phones. So why not teach them in the digital world that they live in and teach them with what they relate to, which is simply games and apps and things like that.
That's really awesome,
Okay.
Cyril. Yeah. Hi.
Well, thank you all for attending.
Yeah. So that was really, really interesting. And
Uh,
one more last little question from Robert, I think. Is saying, what about Chromebooks? He says.
Chromebooks. I haven't experimented with Chromebooks, but I would assume HTML will work, wouldn't it?
Mm-hmm. Yeah, you could go with a web app there. Yeah. Yeah. Okay. All right. Well, I think we need to draw this one to a close. We've got Richard waiting in the wings. Richard is going to bring us a session on user interface. So, yeah. Todd is saying Chromebooks. Yes. Okay. All right then. So I'm gonna wind this up. Thank you so much, Cyril. That was really interesting.
Okay.
And folks, come back again in a couple of minutes, and hopefully I will have Richard for you. Okay. Bye-bye.